Hey there, everybody. It's April 27th, 2022. It's spring 2022 semester at College of the Sequoias, and we're right near the end of the semester. This is Introduction to Statistics. This is one of our last lectures. Our last lecture will be Monday. Next Wednesday will be for wrap up and in a review and stuff like that. You want to work on project stuff. But today we're covering three populations, and if they have it's a proportion thing still, kind of. It's kind of in the proportion category, but there can be more than two responses. In the sample problem we can see on the screen right now, there's people were asked which would they pick, money, health, or love. So if we group people by their responses, we have three different populations: those that said money, those that said health, and those that said love. Now, this problem only did it tested by gender, but we could have done it by age range and had 5 different age ranges, with each row having a different response for each one. So this is a way of doing a nice test when there's more than 3 or more populations and you're trying to get some information where it's proportion wise. So this is 12.2 in our stuff. And this is called the chi-square test for independence. It's also it's a contingency test. In fact, I'll put it in like the table dash contingency test. As you'll see, well, you can see from the problem right there. So this occurs, the chi-square contingency test, like I was saying, is 3 or more populations. And we can have multiple subgroups within it. Subgroups or responses, stuff like that. Frequently, most times, most often, the data is organized in the table. Or can be. They may give it to you in a sentence, but they may, which you can still take it from the sentence and make a table out of it. The way we're going to have this is our populations will be across the top. So will be columns. Which is across the top. And we'll have our categories down the side, or rows. Down the side. Like here, money, health, love are population, the columns with the headers at the top, or the labels at the top. So labels across the top. And for the rows, the labels are men and women. Those are down the side. In fact, it's important. Notice that the first column here, it doesn't actually say a column, but the first column is row labels. Now, this is important for StatCrunch, maybe not all statistics software, but this is important for StatCrunch. So that's our first column, and then columns 2 onward. Two to 4 or higher contain the summarized data. Okay. Usually, Stack Crunch is usually we're going to go stats, tables. Well, we're going to do this first part every time. Stats, tables, contingency. And then the most frequent outcome is with summary. As we'll go take a look at right now. Stats, tables, contingency, and with summary. So that's our most common. But there are problems where they give you all the results as data. I think we're looking at one today. And then with data is also an option. Is a lesser used option. But it can be used. I'm going to just click on this with summary right now before we dive into actual problems and take a look at what you need to click on in here. So in StatCrunch, what do I choose? So for the select columns prompt, which is the top one, pick all the rows with data, or all the columns with data. With summarized data, basically. Then it also asks for row labels. So if we look at our first sets of data, let's see. If I'm doing that money, health, and love thing, my data is in the money, health, and love. My row labels are gender-based. So we're going to look in gender for those. So that's the second prompt that you need to fill in. Row labels, select the row select the column that contains the row labels. Which means you may need to type them in. Okay. And finally is the display. And the most common one we're going to choose is expected count. Is most common. I will show you some of the other ones and what they're good for after we go through some examples with these, or after I at least do an example with this, but I think we should give you that information. I'll give you a second to write that down. That dog just keeps howling in mine. We'll come back to that in a second. If you need this up longer, give me a holler and I'll put it back up. Let's take a look at the requirements real quick. So requirements for the chi-square test. for independence are similar to the goodness of fit. The only difference here is the goodness of fit test generally has one column that you're just making sure everything matches up. And the contingency table, there's more than one column. So all categories have counts greater than or equal to 1. Which means no 0 categories. Every category needs an answer. And then the part 2 came in 2 different flavors. No more than 20%. Have counts lower than 5. And another way of writing that is at least 80% have counts greater than or equal to 5. Those two things are kind of like the same, the last two. All right, assuming those are all met, how does our hypothesis test work? Well, remember, there's 5 steps, and for most of them, all the steps are the same except for the first step. So step 1 is identifying the hypothesis. So H naught and HA for this chi-square test for independence is that the row and column variables are independent. And the alternate is there is some form of dependence between column and row. All right, so I'm doing the notes I'm using are in the file section, the lecture notes. And this is on 12.2. The problems are already in there. They're easy to grab and use. And I've actually typed in some of the stuff into StatCrunch to save some time. But we can, where is my mouse? There it is, way over there. We can look at that question again real quick. I've got this data stored if you want to load it yourself. You got to do a search for data sets by Jones, Hefe, chapter 12.2, contingency table. But you don't have to if you just want to follow along with what I got on the screen. Well, actually, we can start with this one. And we can be a little clear on, I can be a little more clear on, or make it H naught and HA make a little more sense here. So for our example number 1, This is on the money, health, or love. And then it's guys versus girls. So we've got got a big table. There's multiple responses. The H naught here is rows and column variables are independent, which means gender, which is my rows, doesn't influence the choice. And HA, that is the opposite. Gender has an effect on what someone chooses as a response. Like if you watch movies all the time, the girl is always the romantic, wants to fall in love, blah, 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 blah. And the guy is always like business related. I'm chasing the money. And is that like really true? Are women are likely to pick love over men? Or is it really just the same proportion throughout both groups kind of thing? So that's how this kind of works. And that should say gender if it's not clear. Gender. Give you a second to write that down and we'll take a look at the test. Okay. Let's have a look-see. Let me know if you need it up, of course. So step one was H naught and HA. We did that. Gender doesn't affect choice. And HA, gender does. Step 2 and 3 are kind of related. They're both just collect information steps. One of the things is to find alpha. And alpha, our level of significance, is given to us in this problem as 0.05. And then we need our p-value, which I'll write to the left. And we need our test stat, which I'll write to the right. But first, we got to do the actual test in StatCrunch. So let's come over to StatCrunch where we got the information preloaded. And again, we've got multiple columns. If I don't have the gender column typed in there, I need to type them in. And you'll see why as soon as we do the calculation. This is stats, tables, contingency. And we're going to do with summary. So for the select columns, we're going to choose the columns that had responses with data in it. The row labels will say what column the row labels are stored in. And I'm going to do expected count. So those three things: select column, row labels, and display. The only test we're going to do in this class is hypothesis test. This is obviously just an introduction to statistics. There's a lot more that they can do. Ooh, a heat map. So let's take a look at how the responses read and what we're looking for here. Notice it says count right here and expected count. So the expected count is in parentheses. And this is the values we expect if they are independent. So it's kind of like the closer this value is to this value and going across the every category, the closer they are, if they're all really close, in fact, if they're all spot on, they're absolutely independent. The closer they are to it, the more likely they're independent. If they're so far away, we will get a p-value like we did here. So our chi, it says this statistic is chi-square. That's that symbol. And we're getting 36.8396. My p-value is less than 0.0001, which means 0.001 is greater than the p-value. All right, so step 3 or 4, make a decision. So 0.05 and alpha, or our p-value, 0.05 is higher. Alpha is greater than p-value. If I write it the other way, p-value is less than alpha. When the p-value is less than alpha, we reject H0, we reject the null, we reject the hope. So reject H0, support HA. HA is gender affects outcomes. There is significant or sufficient evidence to support the claim that there is a relationship or dependence between gender and what is the columns for this? What is it actually representing? Let's go back and look at the word problem. If you could have only one of the following, between gender and life choice, maybe I'll call it. And that's how this works. This contingency table is actually really handy for one other thing, a couple other things. And I will show it to you. If there's any questions on this, let me know. Otherwise, we'll dive into another topic real quick while we have this up. All right. So I'm going to go back and look at my other options we had here. We had row percent, column percent. I want to show you what those are. So if we choose row percent, for the display option, What StatCrunch does is StatCrunch finds the total in each row. And divides each entry in that row by it. So right now, men and money says 82 was on the table. The total in the row was 883. So 82 out of 883 is 9.29% or 0.929. We studied this before. This is called conditional probability. And we did it back in chapter 5 when we were doing probability. The way we worded it back then was the probability that a person would opt for money given that they are a guy. We had a little formula for it. We had like probability of F given E, probability of F given E happened already. So it's kind of like you have all this data, men, women, money, health, love. There's a whole lot of responses. But if you're not caring about the entire population that answered this question, you're only caring about men, you're restricting it, you're putting a condition on the sample that you only want men. And so we have a conditional probability. The same thing happens with column percent. If I change this to column percent and look at the same category, there was 128 people that said money. For money. 82 of them were men. So I have 82 over 128 is 64.06%, which is 0.6406. And while this up here was probability that the response was money, given that it was a guy for the rows, or the row stuff, the column percent is the probability that the person is a guy, given that they chose money. So you can use this stuff for conditional probability, which is handy. Like if you don't care if they responded health or love, you only want to know if they responded money and what the percentage breakup was. This is one way of grabbing it quickly from the table, and it provides it for you. It does it for all of them. So if I go back to row percentages, these row percentages should be pretty much the same between men and women if it's independent. And it's not. 9 is almost twice 5%. 50% is quite a ways from 64%, and 40% is a lot higher than 30%. So for the group that opted for love, there's a lot more that were guys. A greater percentage of men opted for love than women. So that whole story about on the TV show about how women are the romantics doesn't look like it's true. Looks actually like it's the other way around. Women want to be healthy. They're like, you can have your money, you can have your love. I want to live forever, for as long as I can. And maybe that's why women live a lot longer than guys. Well, not a lot longer, but they live longer. The average is a couple years longer. I wonder if that's why. I wonder if it's because they opt to choose health. That's an interesting question. Huh. All right, so that was that question. Let's take a look at another one. So this was on a group of COS students. They did this experiment for their group project. When we do it when we have in-person statistics class, we do team projects, or at least my class does. A group of COS students happened to work at Cold Stone Creamery, and they thought that gender and size of ice cream ordered were related. So they collected data. The sizes at Cold Stone Creamery are not small, medium, or large. They're like it, love it, or gotta have it. So they got permission from their boss to do this test, and they collected responses for if you liked it, which gender you were, if you loved it, which gender you were, if you were a gotta have it, which gender you were. And just eyeballing it, the women opted for a small size the most, and then the bigger the cup got, the lower the values got. Less women opted for it. And the guys were the other way around. If it was a small cup, they were less likely to choose it. More guys picked larger cups. So I'm guessing that gender, and I'm with the students. I think their suspicion is correct, that gender affects the size that you order when you get ice cream. But let's test their claim. So this is our Cold Stone Creamery problem. That's a dead pin. Grab another. Cold Stone. Let's just rewrite that word, creamery problem. And the claim is gender was related to ice cream size. Of cup. And it says they want to test the claim at alpha equals 0.05. And the data's in the table right there. I've already got loaded in StatCrunch. We'll take a look at it right here, right now. So let's go walk through our steps. H naught and HA, step 1. H naught and HA. H naught is that they are not related. H naught is gender does not affect cup size. And HA is size matters to gender. All right, step 2. Let's get our p-value going on. Let's get our test stat, which is going to be chi-squared. We'll come over here. And I will, again, we're going to go stats, tables, contingency, and we're going to go with summary because the data is summarized. The categories here are like it, love it, gotta have it. I didn't retype new row labels because they were both still just guys and gals. So it's in the gender. And I'll go with expected count. I got to go a little bit lower. There we go. All right, so my p-value is less than 0.0001. Chi-square is 49.685324. That's a big number. So that's step 2, and step 3 is with alpha. Alpha is 0.05. We're going to make a decision. Step 4, decide. So I've got alpha equals 0.05. So p-value, which is less than 0.001, which is less than 0.05, which is alpha. So p-value is less than alpha. P-value is less than alpha. So the p-value is too low. We reject the HO, or the null must go. Reject H0, support HA. And we finish it off with our statement. We're supporting HA. HA is the student's claim that gender was related to the size of the cup that they chose. So there is sufficient evidence to support the student's claim. That gender affects the size of ice cream purchased at Cold Stone Creamery. Any questions on that one? All right, I'm going to take a look at a homework problem. Let's walk through number 5. Homework for chapter 12-13, number 5. So here it says a survey of 36 students was conducted to see why students dropped a course. So we're looking at the data set. The first male dropped it, didn't like the course. Second male dropped it, didn't like the course. The third person asked was a female. Work got in the way. Fourth person asked was a male. Something going on in their personal life made them drop it. Maybe a family member got sick. Maybe they had a child. You never know. Something happened. There's different reasons to drop a course. It says construct a contingency table for these two variables. So it looks like we're trying to see if gender is independent of the reason that they drop. So H naught is gender and drop reason are independent. And HA is they are dependent. And it says construct a contingency table for the two variables. I could go through and add those up and just count them all, but I think that's tedious and there's a good chance I'm going to mess it up. So I've got the data. Let's go with the tables contingency with data option. So I'm going to look at my full data set. I'm going to do that. I'll open in StatCrunch. And it's got my genders in one column and my reasons they dropped in another. So let's take a look at StatCrunch and see what it says when we do the tables contingency with data. So it wants to know what column contains the row variables. That's in the gender column. Because they told us in the problem they wanted the rows to be guy and girl. And the columns were going to be the drop reasons. And I'm going to do expected count. And we'll take a look at what we got. So my outcome is, and I'm going to write them down because I'm betting the school did, or the problem did males and females. So the order might be wrong. So let's just make a table real quick. I've got female, male. I've got course, I've got personal, and I've got work. So this was 7, 11, and 3, 6, 3, and 6. Your results may vary. I'm just pulling it from here. It says this is the count, and that's where they got the count. So they counted it up for me. I didn't actually have to go through and count them. That's pretty nice. While I'm here, I'm going to write down the chi-square and p-value too. I think that's a good option. So chi-square is 4.78111617, and my p-value is 0.0916. If I write it all down now, I may not need to come back. All right, having done that, let's go back to the problem. And look at that, they got male on the top. So I got to make sure I line these up. Male was 6 for course. And then I've got 11 for, or nope, 3 for personal. Why does it keep trying to scroll down, jerk? And 6 there. Here I've got 7, 11, oops, wrong number, and then 3. I want to test whether the gender is independent of drop reason. For this chi-square test for independence, gender and drop reason are independent, and then gender and drop reason are dependent. Those are my H naught and HA. My p-value, I actually recorded it. That's good. I don't have to go back and look for it. So if I want to do my test, let's just take a look at it. Did it give me an alpha anywhere? At alpha equals 0.1. My p-value is actually less than alpha, isn't it? If it had been 0.05, it wouldn't be, but right now it is. So this is going to be reject H naught, support HA. So I'm supporting HA. There's sufficient evidence to support the claim that gender and drop reason are dependent. And I'm rejecting H naught. That looks like A. So that's an example of walking through that. Well done. Any questions? All right, I got an option for you. So this, oh, I see a chat thing. Let's see what we got. No questions. All right, here's my question for you. I've got one section left and I can get it done in the next hour. We can get all the lecture done today, if you so choose. Then next week, attending class will be optional. I will be here from 2 to, if we do it today, I will be here from 2 to 4 on both days, Monday and Wednesday, to answer questions, either homework related or project related, especially with your project due the following Monday after that. And that way you'd have all the lecture now, or we can wait and you can stop and not have any more lecture today, and we'll do 13.1 on Monday. What do you guys think?
Mr. Jones?
Yeah.
I think I'd rather do the rest of the lecture on Monday.
All right. I got a response. That's what we'll do. Then we are going to call this lecture a wrap. If you guys don't have any questions, that's the content for it.
Mr. Jones?
Yeah,
After the lecture on Monday, could we still ask questions and stuff?
of course.
Okay.
And you can ask questions for the next hour too. I'm just going to hit stop recording for now because the lecture part's done.